Assalamualaikum and greetings everyone. Today I'm going to show you another example of reversing the order of integration. Let's look at question number 1. Here the integrand is x cubed plus 1 square of that. The order given is dx dy. Obviously this would be easier to evaluate if the order is reversed to dy dx. Okay, I need more room. Okay, the first step that you need to do to reverse the order of integration is to sketch the region of integration. The region of integration can be obtained by getting the limits of x and y. Okay, now let's look at the limits for y. The limits for y are 0 to 1. So from there we get two equations. From the upper limit we have y equals 1. From the lower limit we get y equals 0. And then let's look at the limits for x. The limit for x, the upper limit is 1. So we have another equation, which is x equals 1. And the lower limit for x is square root of y. So that would give us another equation. We have x equals square root of y. Okay, the next step is to sketch the four equations. As you can see, we have three straight lines. And this is this one is only part of the parabola. Okay, first step, the x and the y-axis. Let's sketch this. So we have the y-axis and the x-axis. Okay, let's sketch the straight lines first. So we have y equals 1. So y equals 1 is a horizontal line. So let's say this is y equals 1, and then we have x equals 1, that is a vertical line. Okay, let's say this is x equals 1. Not very pretty there. Oh well, we have x equals 1, y equals 1, and y equals 0 is the x-axis. Okay, let's sketch x equals square root of y. If you don't recognize what this is, okay, let me see. Here we have x equals square root of y, so we know that here x is larger than 0, larger than or equal to 0. But if you don't know the shape of this, you can do some mathematical manipulation. By squaring both sides, we have x squared equals y, and we know that this is a parabola. Y equals x squared, parabola. But remember, we only take the positive y. Okay, so parabola open upwards, goes to the origin and also through this point. So we have part of a parabola, which is really y equals x squared, or x equals square root of y, because we only take the right side, because here x is always larger than or equal to 0. Okay, and then we have the y equals 0. Y equals 0 is just the x-axis. So from there we can shade our region of integration. So this is our region of integration. Okay, all right, now let's evaluate this by reversing the order of integration. But first we need to get the limits for our new integration. Okay, let me copy this. Okay, so here we have our double integral. Okay, now we want to reverse the order of integration, meaning now the order of integration is dy and then dx. Okay, so if it's dy and then dx, x would be from a constant to a constant. Remember, the outer integral, the limits must always be from a constant to a constant. Now looking at our region here, the lower limit for for x would be the y-axis, where x is 0. Okay, on the y-axis, x is 0. Okay, and the largest value for x here would be this blue line. Okay, the blue line is when x is 1. Okay, so that is upper limit for x. Alright, now we need to get the limits for y. To get the limits for y, we just draw a straight line parallel to the y-axis across our region and see which one is the top boundary and which one is the bottom boundary. So from here we can see that The top boundary is the red curve, and the bottom boundary is the x-axis. So the bottom boundary x-axis is when y is 0, and the top boundary governed by this equation where y is equal to x squared. Okay, now we can evaluate this. Alright, so remember we evaluate this by integrating the inner integral first. So here the integration is with respect to y, so x will be considered as constant. So x cubed plus 1 here, square root of that is considered as constant. Integrate with respect to y, so we get y, and then replace y with upper and lower limits, 0 to x squared. Replacing y with upper and lower limit, we get upper limit minus the lower limit, so we have x squared, x cubed plus 1. Okay, now we need to evaluate the outer integral. So here we can use substitution method. We can let u as x cubed plus 1, and from there du is going to be 3x squared dx. So x squared dx is du over 3. Okay, now replacing x cubed plus 1 as u, so we have u, square root of that. X squared dx is replaced by du over 3. Okay, and then we can use the limits for x and y to get the limits for u. Okay, the upper limit for x here is 1. So from there, when x is 1, u is 2. Okay, because u is x cubed plus 1. So when x is 1, u would be 1 cubed plus 1, which is 2. So that would be the upper limit for u. And the lower limit for x is 0. Okay, again, when x is 0, replacing x with 0, we get u is 1. So that is the lower limit for u. Okay, you don't have to do this. You can always use the upper and lower limit for x, but then you have to change u back to x cubed plus 1. Okay, now integrating u to the power of a half, that would give us a half plus 1, that would be 3 over 2, 3 over 2, and then replacing u with upper and lower limits. So here we get 2 over 9. Replacing u with 2, so we have 2, 3 over 2, that would be cube there. Okay, and then we get this is 2 square root of 2. And minus, replacing u with 1, we get a 1. Okay, simplify this, we get 4 square root of 2 minus 2 over 9. Okay, so that is how we change the order of integration. Let's recap. First, you get the limits for x and y. Then you end up with 4 equations. Sketch the 4 equations on the xy plane. Shade your region, and then from there you can get the limits for x and y using the new order of integration. Okay, all right, thank you.